Hello everyone. Okay, so in this video, we are looking at cubic functions. So we're going to be learning how to graph a cubic function, and then we're going to be solving problems with cubic functions. So, a cubic function, right? So we've looked at linear functions, we looked at quadratic functions. Now, cubic functions is just a one step ahead. A cubic function has a x cubed term, right? It has an x cubed term. So a cubic function is in the form, so this is the general term here. Ax cubed plus bx squared plus cx plus d, right? So if we have something cubed, it is going to be a cubic. And this is an example of a cubic plot out here. So this is an example of the cubic x cubed plus 7x squared plus 7x minus 15. So you see here, it has three distinct roots. 1, 2, 3. It has three distinct roots. And then the thing about cubics is it will have a maximum turning point and a minimum turning point. So there, for example, there's my maximum turning point, and there's my minimum turning point, right? My maximum's here, my minimum's here, right? So it's very important to know that you could have a maximum turning and a maximum maximum turning and a minimum turning point. So what do cubics look like? So the leading coefficients, if x cubed is positive, so if we have a positive x cubed, the right arm points upwards. If x cubed is negative, the right arm will point downwards. So it'll start from the bottom and go to the top. And then if it's negative, it'll start at the top and it'll go to the bottom. So this goes for all functions, really. If the leading coefficient is negative, it points downwards. If the leading coefficient is positive, it points upwards. So remember, positive people go to heaven, negative people go to hell. You know, positive functions go to heaven, negative functions go to hell. Just remember that. So, how do we plot a cubic function? The exact same way we've been doing it, right? The table of values method. So you set up your 4 columns, your domain, so your inputs, your function, so you workings, you sub your input in, you have your output, and then you have the corresponding coordinate, right? You plot them points on a coordinate diagram, same scale, join the points together, bada boom, bada bing, you have plotted a cubic equation. So, let's have a look here. Draw a graph of the function f of x equals x cubed minus 5x squared plus 3x plus 9 in the domain minus 2 to 4. So, minus 2 to 4. So, what we do is, right, you could, right, inputs, my function, my outputs, and then my coordinate. So, -2, -1, 0, 1, 2, 3, 4. I can then sub them in. So what's my function here I'm subbing in? X cubed minus 5x squared. So it'd be -2 cubed minus 5 times -2 x squared. So what's the rest of it here? Plus 3x plus 9. So plus 3 times -2 plus 9. Right? So ding dong y there. Right, so if I put that in, I should get, I believe, 25, I'm pretty sure. -6 for, so -20, -20, -6, -26, -26, 17, 17, -17, -8, -25, right? And then my point here is -2, -25. You have the other point here, -1 cubed minus 5 times -1 squared minus 3 times -1 plus 9. Put them all together, I think you should get x is equal to 0. And then you have -1, 0 here. Now you could do this for all your points, but like I said, effort of that. So what we are going to do is we're going to use our calculator to make a table of values for us. So open the calculator, exact same process, right? So menu, table, type in my function. So my function is x cubed minus 5x squared. So x cubed, so remember alpha, right bracket, cubed, minus 5x squared plus 3 times x plus 9. I'm starting, So leave g of x, leave that alone. I'm starting at -2. I'm ending at 4. And I'm going up in ones. So there you go. There's my table of values there. So I have all my points here. So make sure to kind of write them down on the page just in case you don't want to lose any potential attempt marks. But let's plot this out. So my first point is -2, -25. So -2 here, -25 is here. That's my first point. -1, 0. That's that there. 0, 9. So 0, 9. That'll be roughly around here. 1, 8. So 1, 8. That'll be roughly around here. Let's go down. 2, 3. So 2, 3. That'll be around here. 3, 0. 4, 5. There we go. So let's plot these together. So ding, 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 ding. So there is my cubic equation there, plot out. So how many roots does it have? It doesn't answer the question, but it has one root here, but then it only touches the x-axis once at x is equal to 3. So it has an equal root, right? So it has 2 distinct roots, really. So it has 2 distinct roots, but it does have 3 solutions there. So let's look at the questions. Find where f of x equals 0. So that is asking us where it crosses / touches the x-axis. The x-intercept, right? So that's asking for the x-intercept here. Well, it crosses at x equals -1 and when x is equal to 3. So that happens at x equals -1 and x is equal to 3. Find the value of x for which f of x equals -10. So -10, I'm given the y value, f of x equals -10. So I need to go to -10 on my graph, draw a parallel line, see it hits it at this point here. There it is. I go up, bing, 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 bing. That's -1. This is -1.5. So this is going to be -1.4. So when x equals -1.4. Evaluate f of -2. So remember, this is my x value. I'm given my x value. So I go to -2 on my graph. Go to -2 on my graph. On my x-axis, I should say. Go to -2 on my x-axis. Go down. Ding, 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 ding. Hits the graph at that point. Go across. Ding, 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 ding. -25. So my function is equal to -25 when x equals -2. The maximum turning point. So the maximum turning point would be this point up here. So it's called turning point because it goes from increasing to decreasing. And that happens around this point. And I'm going to say that happens roughly... let's just see. Did I draw this graph very well enough? Probably like that, really. But again, hit marks, really. So I say it's going to happen here. Ding, 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 ding. So happens at 0. And x equals 0.4 and when y is equal to 10. That'll be my maximum turning point. So 0.410. And finally, the range of values for which f of x is greater than 0 and decreasing. So we want to find out where it's above the x-axis, but it's also decreasing. It's going down. So we need to look at the region that does that for us. So if we look at this region here, well, it's get rid of that. If we look at this region here, we see it's increasing, yeah? It's increasing, but that's no use to us. We're looking for decreasing. So where's it decreasing? Well, it's decreasing here, right? And we also notice as well, it is above the x-axis. F of x is greater than 0. So we're looking at this region right here. So between this point and this point. So when x is greater than 0.4, but x is less than 3, my function is above the x-axis or positive and decreasing. So 0.4 is greater than x, which is less than 3. Right? Again, you do have margin of error when you're plotting and working with graphs, okay? Because no one can be perfect drawing them, so you are given a margin of error to work with. Right, let's look at some exam questions now. So this is from the 2023 Leaving Cert Ordinary Level paper. So this is question 4. The graph of the function g is shown on the coordinate diagram below. Right, so we have a function shown below. Estimate the value of g of 1.5. So g of 1.5, I have my input here. I'm given my x value. If I'm given an x value, I go to 1.5 on my x-axis and I go up and see where it hits. It hits it here, and I go across and read it. 2. So when g of 1.5, that's going to be equal to 2, right? And make sure, look, it says here, show your workings on your graph. So you could have typed that in your calculator, but it's asking us to show our workings. Estimate the value of x for which g of x equals minus 6. So again, look, g of x equals minus 6. So I'm not given an x value here. I am given my y value, because that's g of x is another way of saying y, right? So my output is equal to minus 6. So I go to minus 6. There, I go across, bing, hits here. I go up and read. Boom. So that'll be, so that's 2 minus 2.5. That'll be probably halfway between that. So like minus 2.75? Minus 2.75? And show you working the graph. Show, tick one box to show how many real roots the function g of x has in this domain. So how many real roots does it have? So a real root just means how many times it's across the x-axis, and it only crosses the x-axis once. It only crosses up here. So we say it has one real root. Give a reason for your answer. The reason for my answer is it crosses x-axis once. That's it. Bada boom, bada bing. That's it. Right, then finally from the graph, estimate the coordinates of the local maximum and the local minimum point. So maximum and minimum points. So I need to find my local maximum and local minimum. So that just means the the turning point here, I'm pretty sure. Let me just double check. So they're looking for the maximum and minimum turning points. So that's going to be this value here and this value. So let's look at these now and see. So, when x equals minus 1.5 and y is equal to minus 1. So that'll be my first point here. So minus 1.5 and minus 1. And then that'll be my local maximum. And then my local minimum point would be so it's around here. So not minus. So 0.25. And my y value is going to be minus 3.1. Right? And that's it there. Okay, so let's now look. So my local minimum, that's going to be minus 1.5 minus 1. And then my local minimum is going to be 0.25 and minus 3.1. Right. Let's look at this one here. It's a practice problem. Draw a graph of the function 2x cubed minus 5x squared minus 4x plus 3 in the domain minus 1 to 3. Find where f of x equals 0, the value of x for which f of x equal to 6. Evaluate f of minus 1. Find the local minimum turning point. And then find the range of values for x for which f of x is greater than 0. So let's have a go at this. So we need to plot this out. So again, I'm not arse plotting things out, so I'm going to use my calculator. So use my calculator, boom, type in my function. So my function is going to be equal to 2x cubed minus 5x squared minus 4x plus 3. So I'm starting at minus 1, ending at 3, and I'm going to go up in ones. So let's have a little general scope of what my y values look like. So my maximum y value would be 3, and my minimum y value would be minus 9. So I'll work with that for my range here. So 1, 2, 3. Minus 1, minus 2, minus 3. Minus 4, minus 5, minus 6. Minus 7, minus 8, minus 9. Right, so let's plot these points, shall we? So minus 1, 1, 2, 3. So let's plot these points. Minus 1, 0 is my first point. 0, 3 is my next point. My 1 minus 4 is my next point. 2 minus 9. And then 3, 0. 1. So there you go. 1, 2, 3. I have 3 distinct roots there. So find where f of x equals 0. So let's answer these questions. I find where f of x equals 0, so i.e. where it crosses the x-axis. Well, it crosses the x-axis at x equals minus 1, x equals 3, and x equals 0.5. So x equals 0.5, x equals minus 1, x equals 3. Find the value of x for when f of x equals 6. Right? Oh god, we probably have to extend this graph now a little bit. 4, 5, 6. So let's go here. So this is going to be 4, 5. So let's extend the graph off a bit. Right, so extend off my graph. Let's see. f of x equals 6. I go to 6 on my y-axis, go down, ding, bong, go down. So it's going to be 3.6, roughly. 3.6, roughly. Evaluate f of 1. So again, I have my x value here, so I go to 1 on my x-axis, and I go down and see and read it. So I go down, hits here, go across. That's going to be minus 4. So f of 1 is going to be equal to minus 4. Find the local minimum turning point. Well, that's going to be this right here. This point right here, which is equal to 2 minus 9. That is going to be my local minimum point. And then find the range of values for which f of x is greater than 0. So it is positive or above x-axis. So we want to find out where it's above the x-axis. Well, it's above the x-axis between these points here, these points, and these points. So between minus 1 and 0.5, and when x is greater than 3. Right, so when x is between minus 1 and 0.5, it's positive, and then when x is greater than 3, that is when it is greater than 0. So let's look at one last question here. So this one now is a real life problem with cubics when we are dealing with volume. They love to ask cubic functions along with volume. So let's have a look at this question here. So a question, so this from 2021 Leaving Cert O-Level paper. So a square sheet of cardboard of side 10 units is used to make an open box. Squares on the side x units where x is an element of R are removed from each corner of the box and is then folded along the dotted line as shown in order to create the box. So the length, breadth, and height of the box are shown in the diagram below. Write the length, breadth, and height in terms of x. Well, it's a square, right? It's a square. So that means this side is 10, this whole side is 10, this whole side is 10, and this whole side is 10, right? The whole side is. But they're being cut out of the box, right? These little X indents are being cut out of the box. So here is actually going to be just this region here. That is going to be, actually I'll do it here, probably. So this is going to be X and this is X. That means this region here is going to be 10 minus 2x. 10 minus 2x. And again, it's the same in here. So this region here is 10 minus 2x. So the length and the width here are the same. Now we just need to think about the height. Right? So the length of this box here is 10 minus 2x. The width of this box is 10 minus 2x. But what about the height? Well, if you realize, if you fold these corners up, this region here, this one right here becomes my height. So if you actually fold it up, that becomes my height. So the length is going to be equal to 10 minus 2x. The breadth is going to be equal to 10 minus 2x. And the height is just going to be equal to x, right? So this little part here, right, when that's folded up, that will become the height of the box. Show that the volume of the box can be written as 4x cubed minus 40x squared plus 100x. So we need volume. Volume is equal to length by width by height. So 10 minus 2x, 10 minus 2x times x. Multiply these brackets out. I'm going to get 10 minus 20x minus 20x plus 4x squared, all times by x. So I'm going to have here, oh sorry, that's 10 times 10 is 100, sorry. 100 minus 40x plus 4x squared times x. Multiply x in, I get 100x minus 40x squared plus 4x cubed is equal to the volume. And that is exactly what I have proven. Right? So there you go. Bada boom, bada bing. Sources. Explain why a box of height 6 units cannot be made from the sheet of cardboard. Well, the box of height of 6 units cannot be made from the cardboard because if you look up here, this is my length and width, right? So my length and breadth is equal to 10 minus 2x. If x is equal to 6, right, because x is my height. If x is equal to 6, the length will be equal to 10 minus 2 times 6, which is equal to minus 2. So 10 minus 12, which is minus 2. So you can't have negative dimensions with length and width and stuff. So you have to say the length and breadth will be negative as 10 minus 2 times 6 equals minus 2. You cannot have negative length. Right, there There you go. Bada boom, bada bing. Right, next one here. This is an easy peasy one. A table of values. In your Leaving Cert exam, they ask you to fill out a table of values, and you can use your calculator for it. That's easy, mate. Right, so what do we have here? So I have complete the table of values for this function, 4x cubed minus 40x squared plus 100x, in the domain 0 to 5. And if you see here, we're going up in increments of 0.5. So let's just put that in a calculator. Easy peasy, lemon squeezy. So open up a calculator. There it is, table. Type in my function, so 4x cubed minus 40x squared plus 100x. I'm starting at 0. I'm finishing at 5. But I'm starting at 0, finishing at 5, and I'm going up in 0.5. So I'm going up in halves. And there we go. So 0, 0. 0.5, 40.5. 164. 1.5, 73.5. 272. 2.5, 62.5. 348. 3.5, 31.5. 4, 16. 4.5, 4.5. 5, 0. That, oh sorry, let me see the last bit, but like, come on, like that's easy marks. Easy marks. Right. Let's look at the next one here. It's probably asking us to plot. Oh, it's asking us to plot it, ladies and gentlemen. It's asking us to plot it. Right, okay, let's get a calculator back up. Right. Draw the graph of the function Vx on the grid below. So, let's do this. So, 0. 0, 0, first point. 0.5, 40.5. So, that is going to be just like in here. So remember, it's going to be here. So remember, it's 40.5. So it's between 40 and 41, not 40, like not like halfway between 40 and 50. Some people get confused with that. 164. 64 will be around here. 1.5 is 73.5. So that'll be around here, I say. 272, that's around here. 2.5, 62.5, so that'll be here. 348, around here. 3.5, 31.5, around here. 4, 416. Around there. 4.5, 4.5. So it'll be here, roughly around here, and then 5, 0. So it might necessarily look like a typical cubic, but it is a cubic equation. We're only getting a glimpse of it here. Right. So use your graph, estimate the following. So the maximum volume of the box. The maximum volume the box can be is at this point here, and the maximum volume that it could be would be 75. And what units are we working at? It's very important to remember the units. And it just says units. So it'd be 75 units cubed. The values of x that would create a box that has a volume of 30 units cubed. So we want to find the value of x. We want to find x. We're given the volume. So we're given the volume. So we're given our y value. So we go here. We have two values of x. So it will be roughly 0.4 and 3.5 ish. Now I think I messed up just a tiny little bit with the graph, but again, we do have a margin for error, and it's hard for me to write on an iPad. So 3.5, that was 31.5, so it's there. This connects there. This connects here. This goes across. Boom. Hits. Ooh, go down. 3.6. Right. So x equals 3.6 and x equals 0.4. The volume of the box when x is 2.8 units. So I'm given my x value. I go to x is equal to 2.8. So that'll be roughly like here, I should say. There, go across, and it's going to roughly be equal to 51 units cubed. 51 units cubed. So it's really important to remember how to read a graph, right? And that's it. That is cubic functions. There's some questions on cubic functions, and I hope this video was some help to you guys. And I'll catch you guys later. Bye.